Hi everyone. In this video, we want to look at related and related table. So we are working with a couple of tables here. So the first one is sales and the other one is product. The one on the left is a transactional data. Hence, each product is coming multiple times. And the one on the right is a dimension table, which essentially tells us that there is a unique record for each of the 4 products that we are selling. It tells us the product category that it belongs to and the price as well. You can see that phone is in personal, laptop is in office category, printer and pen are in home office. Now, typically, if you wanted to know the product category, what you would do is to either do a VLOOKUP or an XLOOKUP. For example, I can simply do an XLOOKUP where we are searching for the product. We are searching in the, we're searching for the product in the product column, and then the result is from the product category column. And you get the result like this, right? If you were doing this without these tables, then the formula would look like this. Let me show that to you as well. So we would have written XLOOKUP. We are searching for B4, B12 in column G, and the result is in column H. But then we need to get the price as well, right? To get the price, we will again have to do an XLOOKUP where we say we are searching for the product in the column G, and the result is in the column I, and we get the result like this. And finally, we can now say equal to units multiplied by the price, and you get the value. So once again, we are first doing an XLOOKUP to know the product category, another XLOOKUP to know the price of that product, and then finally we are multiplying all the units with the corresponding price. And of course, now we can apply a filter and find out for each of these 3 product categories, what is the total sales that is there. All right. So let us go to Power BI. And we will first connect to our Excel workbook. So we are connecting to related. Okay, I will have to close the file though. So let me do that. So I just want to call this related on Excel. And we also want to delete the other sheet. And here we want to call it related on Power BI. Perfect. So we select related Power BI. I will select both the tables, product and sales, load it. Okay, now the way I want to create a relationship between product and sales is to go to the modeling view. And as you can see, this relationship has been created automatically. So we have a 1, which means that in the product table, each product is coming only 1 time. And then we have a many here, which means that each of those products is being sold multiple times. If you double click on this line, you can also see that these are the 2 columns which are matching with each other. It's a many-to-one relationship. It's an active relationship. And it also talks about the cross-filter direction, which is single by default. You can make it both as well, which comes into play when, let us say you have 3 tables and they are connected 1 to many and 1 to many. And you would like to access the details from a table, which is not directly connected. It's a more advanced topic, and I might be covering it in a video in the future. But keep in mind that there is also an optimization question that comes up, because cross-filter direction in both might create a problem in terms of the efficiency of the operation. And that's not really used most of the time. So let's focus on this one. But in case you're wondering what the arrow refers to, it refers to the flow here, which means that it is flowing from the one to the many. That is why the direction of the arrow is like this. If you wanted to change it to the both, you could have done that and the arrow will become like this. But that is beyond the scope of this particular video. So let me change it back to a single. What we want to do now is to first create a table in which I want to have my product category, right? In fact, let's keep the product itself, right, like this. Okay, now think about what we want to do. We want to know the total sales. That means we want to multiply the price with the number of units that we have sold, right? So we'll create a measure and I'll call it total sales. Now we want to do a sum x because we want to do an iteration, right? Multiply each unit with each price. The table that we're selecting here is the sales table, that is the many table, what is also called as the fact table. And the expression that we're writing here is that we want to multiply the sales units with the price. But remember, the price will be selected like this, right? It's a related table in which the price exists, which is the product table. So we have to select it like this and press enter. I also noticed that my price does not have a sigma on it, which means it's not a numerical column. So let's make sure to go to transform data and ensure that price is a number. Let me just check that. So units is a number and price is a number as well. Okay, I'm a little surprised that it doesn't show as a number here, but doesn't matter. If we can just verify that, if I keep the price here, it is showing me the sum and that works. Perfect. So in our table right now, let's apply a border and a shadow. And if I keep my total sales in it, this is the result that we get. Now, of course, you would like to verify if the results are correct or not. So let me select the Excel file once again. And let me just make sure that I have the file with me open. Here we go. So you can see that we have the product category and we have the total sales as well. And we want to find the result, right? So let's quickly do it. I'll just do a unique so that we know the 3 unique product categories that we have. And then we do a sum if. And we want to say that in the range column D, we are looking at J10 hash as the criteria and the sum range is column F. So we get 48,000, 27,500 and 39,600. If I do this also with the products that we have, one more time, sum if, column B, select the range and the sum range as well. We get the results like this. So phone is 48,000, laptop is 27,500, printer is 9,600 and pen is 30,000. Let's go back and check. 27,500, 30,000, 48,000 and 9,600. We are getting the same answer. But will this work if I do this with the product category? Let's check that. So if we keep the product category in here and we remove the product, 39,600, 27,500, 48,000. 39,600, 27,500, 48,000. As you can see, everyone, it's working perfectly. So we have managed to do an iterative formula where we're doing a sum x, which is based on a row context. where we are multiplying each one of the units, which is one of the corresponding price, even though the product price belongs in a different table altogether. So one more time, we have the price here and we have the number of units here. Now, what would be a use case for us to go the other way around? That means I want to go from the product table, which is the one table, to the many table, which is the sales table. Now, the only use case you would typically think of is to count the number of rows. Of course, it can be used for other things as well, but most of the time, counting the number of rows is what you want to do. For example, in this case, what I want to do is to find out the number of transactions that have happened for every single product category, right? Now see, if I only want to find the number of transactions for the product, that's not difficult, right? I can just put the product here, and we will keep the price here, and we will change it to the count. And it tells me, okay, I'm not sure if these answers are correct. Let me just verify that. Okay, I want to do it the other way around. So I want to select the product from the sales table, which is the many table, and we want to keep the units. And if I change it to the count, you notice it tells us 2, 2, 4, and 1. That means 4 transactions for phone, 2 each for laptop and pen, and 1 for printer. But how do you do this for the product category? Now, if I try to keep my product category here, it tells us 3, 2, and 4, right? So let's just verify that. So we have 3 in home office, 2 in office, 4 in person, right? So total 9, and that's the answer. So home office is printer and pen. So printer and pen would be 3, which is in home office. That is the answer that you get here as well. Now, if you would like to build a measure, what we can do is we can say that total transactions, and this would be nothing but count rows in what? In the related table, which is sales, right? Like this. So if we keep the total transactions in here, you notice we get the same result, 3, 2, and 4. So remember, the related table is going to provide an entire table to you. Related is only going to pick one value. The reason is that when we're searching for the related product and product category, that means when I'm searching for a specific product, right? Let's say phone, then in the product table, we know that there is only one product category next to that product, and there is only one price next to it. But when I'm going the other way around, when I, for example, I'm going from personal or from phone to the sales table, what is happening is that phone is coming multiple times, right? So what it is going to do is to bring the entire table for me, which is like a filtered table. One way of understanding that is that if I create a new table and I just call it a related table, and if we say related table, you notice that it returns the related table filtered so that it only includes the related rows, right? So if I say product, we get product here. And if I say sales, we get sales here. Now, in this case, what is happening is that we know for a fact that all the different products are mentioned in the transaction and in the sales table as well, right? So that means in the sales and the product table. But imagine what would happen if one of these values was not there. Just as an example. For example, let's say phone did not exist, right? Let's see what will happen. So I'm just going to go to the transform data tab. And what we are doing is that where it says phone personal, I just want to remove this row. So we'll remove the top row, right? Let's close and apply. And we go back to the data view, right? And now when we go to the related table and we say we want to take the related table, which is product, do you see what happens? That particular record has not been picked up. The reason it has not been picked up is because in the transactional data, in the sales data, we have 4 types of products, but that product type does not exist in the dimension table, in the product table. Hence, when we say related table, it only picks up those records which exist. That means it will only return the related table filtered, which includes the related rows. Now, the problem is there is no related row to phone, and that's the reason it is not getting picked up. Let's go back to transform data and cancel that last step. Okay, I also want to save this. So let's call this related and related table. There is also an article on Radacat, which explains this in a little more detail. And there is a file that you can download from this link. I'll just take you through it. So what they're explaining here is that there are 3 tables, right? So we have geography, customer, and the transaction data, which is the sales data. And you notice that the geography key is the matching column, 1 to many. So in the customer database, each geography, of course, has numerous customers. And then in the sales table, obviously, every customer has multiple transactions. So the matching value is customer key and customer key. So if we want to go from, let's say, geography to sales, we can still do that using related table. So it actually flows between multiple tables. As you can see here, I have created a table which has the state province that is coming from the geography table. And I've taken the transactional sales value, which is coming from the fact sales table. And it works. It works because I'm able to flow between all these relationships, even if there are multiple tables.